Lesson 6-2, substitution. Our essential question is, how do you determine what to substitute in a system of equations? And our new vocab word is substitution. This is the second method that we are going to teach you that you can use for solving a system of equations. In section 6.1, we talked about how you can use graphing to solve a system. And now today, we're going to start working with substitution, our second method. Substitution means to replace something with another thing that is equal in value. So to replace something with another thing that is equal in value. Probably the easiest example to use for this would be when you're working with money. A lot of times, someone will ask for change for $1, and that change might mean 4 quarters, 10 dimes, 20 nickels, or a combination of those things. It might mean 2 quarters and then 5 dimes. So making change for $1 is substituting that dollar with some coins that are equal in value. That's just one example of substitution. Now, how we're going to use substitution, we're going to be working with our systems. So like I said before, we've already worked on graphing. That was in lesson 6.1. So now substitution we're going to work on in 6.2, and then in 6.3 and 6.4, we will work with elimination. The idea is that by the end of this chapter, you should really walk away with 3 different options for solving a system of equations. And if you prefer one of these options over the others, then you can just go with that one, because you really can use any of them. You really can use any of them. You might need to do a little manipulating with your equations, just like we did in our graphing section, but that's your choice. Okay, so we're going to teach you all of the methods, and then you will have lots of different opportunities for solving systems using whichever method you prefer. So substitution. To use substitution to solve this system of equations, I want you to think about where your variables are and where the equal signs are in these equations. If substitution means that you're replacing one thing with something else equal in value, what you should be looking for is a variable by itself. So look for a variable that is by itself on one side of an equation. Now, once you find a variable by itself, that's going to be the variable that we replace. So in my first equation, I see it. I see that the y is all by itself, and I see that what it's equal to is 2x plus 1. So what that means is that y has the same value as 2x plus 1, so where the other y is, I can replace it with 2x plus 1 because it has the same value. So now my system, I'm going to have 3x plus, and where this y is, I'm putting in 2x plus 1, and then it equals -9. So, take a look at what I did. I said y is the same as 2x plus 1, so I replaced it with 2x plus 1 in the other equation. Now, what that has done for us is it's created a system where, well, not a system, but it's created an equation with only one variable in it. 3x plus 2x, because I don't even need those parentheses on this one. 3x plus 2x would be 5x plus 1 equals -9. I can finish solving this. This is like equations from chapter 2. Negative 9 minus 1 is negative 10. Divide by 5, and x equals negative 2. So my x coordinate is negative 2. I have half of my solution done right now. Now to get to the other half, I am going to plug this in. Plug in negative 2. I know that x is negative 2, so if I go all the way back up to the top, it said y equals 2x plus 1. Now I can put in negative 2 for x. 2 times negative 2 is negative 4, plus 1 is negative 3. So my y coordinate is negative 3. So the solution of this system of equations is negative 2, negative 3. There's one solution. There's one solution. I solved it and I found that one solution. If I had graphed these, that's the point where they would have crossed. Okay, the next one looks similar to the first one. I see my y by itself, and it equals 4x minus 6. So where the other y is, I can replace it. Now watch what happens when I replace it on this one. When I leave it in parentheses, it makes a difference. It makes a difference. Because there was a coefficient 3 in front of the y, so I'm going to have to distribute that 3 times by 4x minus 6. So that gives me 12x minus 18. And now I can finish solving, same side like terms. So 17x minus 18 equals negative 1. Add 18 on both sides. 17x equals 17. And if I divide by 17, x equals 1. So, for my ordered pair, my x coordinate is 1. I take that back up to the top. You can plug it in either one of your equations, but it's going to be much easier to plug in the first one. So, where the x is, I now know that it is equal to 1. So 4 times 1 is 4, minus 6 is negative 2. So my y coordinate is negative 2. So if I graphed these, if I wrote the second one in slope-intercept form and I graphed them both, they would cross at the point 1, negative 2. This next one, they're both written in slope-intercept form. So you may look at this and want to graph it right away, which is fine. You can do that. But I'm going to show you how you could do substitution instead. What happens on this one is y is equal to 2x minus 4. So where the other y is, I'm going to replace it with 2x minus 4. So my equation will look like this with variables on both sides. So again, the 2x minus 4 was equal to y. When it replaces the other y, I've now got an equation with variables on both sides. So I'm going to subtract away the smaller one. So subtract 2x, which leaves negative 4 equals 1x plus 1. Subtract 1, and x equals negative 5. So for my ordered pair, I have negative 5 for x. And then I can go back up to either one of my original equations. I'll just go back to the top one, have it. Okay, so I put in negative 5, so 2 times negative 5 minus 4, negative 10 minus 4 is negative 14. So you can see that the numbers on this one, that negative 14 is really small. Graphing, it might take you a long time, and it might be a pretty big graph to get to that point for them to cross at negative 5, negative 14. So substitution might be a better method to use on this problem. It might actually take less time than graphing and continuing your lines to get to negative 5, negative 14. Okay, now in geometry, you are most certainly going to see some questions where you have to write a system and solve, especially to find the measures of angles or the lengths of sides in a polygon. So this one says the sum of the measures. So the sum That word right there means to add. So the sum of the measures of angles A and B is 180 degrees. So A plus B equals 180 degrees. The measure of angle A is, the word is my equal sign. So angle A is 52 greater than, 52 greater than. Greater than in this situation means plus, not a greater than symbol. So 52 greater than or 52 more than angle B. Okay, I've got my system. Now my second equation has the A equals. So see what A equals? Replace the other A up here. So that means that I'm going to write it over here. I'm going to have 52 plus B. That's what I'm substituting in for A. And then I still had another plus B equals 180 degrees. So you see I put in parentheses even though I didn't need to, just so that you could see that there was still another plus B after that A, or after that 52 plus B. Now, these are like terms, so I would have 2B plus 52 equals 180. Subtract the 52. 180 minus 52. I'll write it over here. So 2B equals 180 minus 52 would be 128. And then divided by 2, B equals 64 degrees. Then I can go back to either of my equations. A equals 52 plus B. So 52 plus 64. So that would equal 116 degrees for A. So we needed to write and solve a system to find the measure of the two angles. So one of the angles is 116 and the other is 64. You should be able to write a summary now. Remember that this summary was focusing on something really specific. So go back and read that essential question to see how you should word your summary. It was a very specific question that they were asking. And your homework assignment is a worksheet